And we are live, and let's wait here like 10 seconds and then we can actually start. So I don't know when it's actually broadcasted on YouTube. But I suppose, Jose, you can start now if you want. So let's first do all of us. So hi, everyone. And I will right away hand over to Jose for introduction.
Hello, welcome everybody. It's so good to have you all today here. Today is a double take, so I hope you have your coffee ready because it's going to be an intense session, double session. So first, thanks to JetBrains very much for helping in organizing this and also letting them use our platform. That's very welcome. This event is hosted from the .NET user group in collaboration with the user group from Bern and the user group from .NET Central in Luzerne. But let's go over our presentation. First of all, we would like to thank very much Offering Solutions, TVVOW, and ForTexture, as well as to our other collaborators in the Impact Hub or the Stanford Group. And soon, hopefully, we are in discussions with JetBrains. So thanks, JetBrains. We will probably announce it as soon as we have spoken this over. We are doing a SAID in collaboration with .NET User Group Central Schweiz and .NET User Bern, which is led by Daniel Marbach, Urs Edler, and René Leopold. Thank you very much for helping us in convoking your audience in getting up to this content. That's appreciated. But what are we doing? We are organized by developers for developers in order to share knowledge and excite you about the technology networking included. Usually we have beer. Sometimes we're organizing after the call, not today, sorry. And whenever we can, we get pizza. As these COVID times, everything is online, so it would be difficult to get pizza to reach you. Who are we? It's me. It's Paweł Niewolny. It's Michael Stape, our hot chocolate creator and member of Chili Cream, founder of Chili Cream. It's Nigel Finlater, Logan Bunyon, Fabian Gosbring, and Mark Muller. These are the team that compose the .NET user group at Zurich. Thank you very much. And last but not least, what do? We do events regularly. We do quality talks with good speakers and content. We do networking and beer and learning while sharing good moments, and try also to stream and publish events online as we are doing today. And we did the last 3-4 times already, and we plan to keep doing. So as next steps, I would like to give voice to Michael so he can also finish presenting the user group. That's the first time. Michael, can you take over?
Yeah, hi guys. So what can you do to grow the user group? Follow us on Twitter, on our .NET Zurich user group, Twitter handle, and join our meetup group. And also we need speakers. So speakers from the community, not only seasoned speakers like Matthias and Matt, but also just your colleague or your friend you know that wants to talk about technology. Tell them about our user group and ask them to do a talk with us. And also we have an upcoming event for lightning talks. We want you to speak there. So sign up with us. Get in touch with the user group organizers and propose your lightning talk. And that's it. Yeah, again, special thanks to our sponsors. And I'll give the word to Matthias Koch. Matthias Koch is the creator of the NUKE open source project. And I know a lot of you guys know something like Cake or MS Build or something like that. And it's always painful to use those half-baked build solutions. And at one conference where I spoke, I met actually Matthias, and he has a very cool solution that actually for me brought everything into the build system I wanted, a fully compiled build solution. So with that, I hand over to Matthias.
Okay, thanks, Michael. I also maintain the stream here or manage the stream. So let me quickly remove Matt and Jose. Michael, I will keep you in place here. So you can still talk, but let me also share my screen. Screen sharing. Okay. So Michael, you can still ask questions if you think it's meaningful. Otherwise, I will just switch completely to my screen. Okay?
Okay.
All right. So welcome, everyone. Let me also switch to my slides here really quickly. This talk is going to be about modern build automation with C# using NUKE. So this is a project I've been working on for roughly 3 years now. It's a pet project of mine. And yeah, let's dive in. First, a little bit of background, why I talk about build automation, what my background with build automation actually is. So at first I was using MS Build, and I guess everyone used that to some extent at least. But MS Build is not really a handy tool for doing build automation. I mean, we can build and pack properly, easy with that. But as soon as our build pipeline gets more complex, like we want to send a tweet, and I see I have some artifacts on YouTube. Let me quickly check. That doesn't look good. But as soon as we want to do something more complex, MS Build is not really the right choice. After some time, I was using PowerShell to do build automation. That worked out okay, but at the other hand, it's also something that as a C# developer, you're not really immediately familiar with. PowerShell also has a lot of unknowns, I like to call them, because PowerShell, for instance, has this weird behavior of null comparison, and it will automatically unwrap arrays if they have only a single item. After some time, I was also looking at fake, but actually I skipped fake because, again, it's another language. In the team I was at that time, that was before I was at JetBrains, we decided that this would put another requirement onto our team. So everyone would need to know F# because fake is based on F# as a host language. So we skipped fake. And meanwhile, I already left and joined JetBrains, but I was still maintaining a pet project of mine. And for that, I tried to use Cake. And at first, I was quite surprised and very ambitious about it. But Cake turns out, well, not turns out, but it is a scripting approach still. And the issue with scripting approaches is that many parts of the build system are re-implemented. And also, it doesn't really integrate well with existing tooling like IDEs or package managers, for instance. So one question that always arises in context of that is, why do I need a build system on the right, like Fake, Cake, and NUKE, if I have build servers? And for that, I would like to point out the advantages of each of them. So we can actually use them in combination. But for the build server part, the real advantage here is that we can implement a continuous integration process. So what I mean by that is we can just commit and everything will compile on the server side, and I basically just push my commits and have a continuous process of checking my implementation. Second, I have historical monitoring. So by that, I mean that, for instance, when I have certain tests that are flaky, then my build server can actually help me identify that. And I can even cross-branch, I can identify flaky builds and see how many times a certain build step failed or a certain test failed, etc. The third is build parallelization. So for that, that's really something that build servers do well, because the more build agents we have, the more potential we also have to parallelize a bunch of build targets. So let's say we have 10 test projects, then, and we have 10 build agents, then we could execute each test project on an individual and dedicated build agent. The third, and let me quickly check, because I also have the stream on my phone here, but it kind of died, just to have everything in view. And after that, we also have queue optimization. So that is really one thing that I honestly only know of TeamCity, which is supporting that. By queue optimization, I mean that if, for instance, I have a very long build pipeline, but something at the very beginning hasn't changed, like, for instance, compiling core projects, then TeamCity could optimize that in a consecutive build and reuse the artifacts of a previous build. So if you're interested about that, I suggest to better read about it. It's a bit more complex, but it saves quite a lot of time, or can save quite a lot of time. So build systems, on the other hand, have the big advantage that we can execute the build locally. If we would just use build servers, then we don't have this advantage. And, you know, it's sometimes very annoying if you have to troubleshoot an issue and you have to commit over and over again to the repository, and the build server needs to wait until your build finally gets into the queue. And it seems the slides are also a bit truncated, but I can assure you on my screen there, it mentions local execution and feedback cycle. But yeah, the feedback cycle is much shorter because we can just troubleshoot on our local machine. The third is debugging. Another thing that's really, can be annoying while troubleshooting issues on the build server, because in that case, we can just attach the debugger right away locally, and we work with it just with any other C# project. And the fourth advantage is we have no lock-in. So let's suppose at some point you want to switch your underlying build server, and previously you were using, let's say, AppWare, and you have your implementation with the AppWare YAML file, then it's quite hard to, and you want to move to GitHub Actions, for instance, then it's quite hard. You need to re-implement the whole build using the YAML specification that GitHub Actions provides. Okay, and with that said, I will jump into coding, and I hope. So, like I said, I have the stream also on my left here, and I just hope that it doesn't truncate the picture. If so, and Michael, please let me know. Okay. All right. So I have prepared a bit of lineup, what I want to talk about, and this is pictured here. So first we will, I will have a 0 point here, and I will show you how the setup experience works. But other than that, we will talk about the target model, how targets are defined and how we can put them into relation, about parameters, which means how can I get values from the outside into my build. The third is path construction. Then we will look at the solution model, tool invocation, because working with third-party tools like XUnit, NUnit, Docker, and SonarQube, etc., is very important for build automation. We will also look at how you can add support for your own private tools, maybe, or tools that might be missing. Then CI configuration generation. So NUKE actually can generate the CI configuration for you. So all the YAML files and what else exists out there. And then the last couple of bullet points here are around build sharing. So external files is a strategy for build sharing, a global tool, and interface implementations as well. But before we do that, I will quickly create a new project and show you how the setup works in NUKE. So I will quickly just create a dummy solution, basically. And let me see, that should do. New window. Okay. So now my solution loads, and right after that, so give it a bit of time. And now I have a solution with one project. All right, and I want to set up my build with NUKE. All that I do, and I have the NUKE global tool already installed. So if you don't know what a global tool is, all that you do is to call .NET tool, then I think install nuke.global tool minus -- global. That will install the NUKE global tool. It's also written on the website and documentation, but I executed that already. And what that will do is to provide me a NUKE command line tool. And so using that command line tool, I can now start and say NUKE setup, and NUKE will walk with me through the setup experience. The first step we have to decide on is how we want to name our build project. For now, I will just accept the default values. We also have to define where it should be located, which version it should use, in this case, the latest release, and to which solution it should be added. So in this case, I have only one solution. If you have multiple solutions, it might be a good idea to just choose none. But choosing a solution from here will also automatically add the build project to that solution. So for now, I would just pick that solution. And there's also a more extensive wizard that can be used here. But for now, I would just drop out here and finish the setup. Now, if I unfocus the terminal, we can see that the build project here has automatically been added. And we can open that and see if we dive into the CS project here. Let's dive right in. We can see this is based on the .NET Core SDK. NUKE actually also works with the .NET framework, but I wouldn't recommend that. So even with a .NET Core build project, we can actually build .NET framework projects. There's no limitation. But overall, the bootstrapping with .NET Core build projects is much easier. And so what we see if we look into the CS project file is this is actually just a simple application. It's based on the .NET Core app 3.0. I think even .NET Core app 2.1 is supported. But other than that, we have just a simple reference to a NuGet package, which is called nuke.common. That's all, basically. And if we dive into the predefined build.cs, we can also see that. So this is just a console application. We have a public static int main method, which then just passes execution to Nuke as a framework. And while we pass the execution, we also define what build should be executed. So that's basically a reference to our build class, and along with the default targets. So in that case, I execute compile by default. Okay, and so just by having that, we can now execute Nuke again with --help. And what we can see then is it will first build this build project and then output some help documentation. So we can see the targets. Those are the predefined targets along with the predefined parameters. So we can pass verbosity, for instance, or configuration. One really nice thing about Nuke is that with the global tool, we also gain shell completion. So for instance, I have a target clean and restore, and I could just type CL and then hit tab, and it will complete to clean. If I hit R, it will complete to restore. Now, if I continue and say I want the configuration, so there are two, configuration and continue. So let's use configuration, and then right here, I can also complete to release. The same goes with verbosity, and I could say verbosity verbose. So Nuke knows a lot about the underlying model of your build. Okay, and then we could just execute it for now. And since I mentioned before, the compile target is our default target, we can actually also see that. So first, the logo will be printed along with the version, then the restore target is executed, and right after, the compile target. At the end, we have a little summary telling about the different durations of the targets along with their statuses. Okay, one really nice thing about NUKE and that it uses a console application is that IDE support is actually right there. So if I go ahead and I want to navigate to the compile target, I can just do that by hitting Control and then using a click or any other shortcut that you have. Then this works because compile, in this case, usually I like to make some kind of quiz out of that, but in this format it doesn't really work. But usually if I present it at the user groups and conferences, I like to ask if you can guess what kind of construct the compile target is. So in terms of C# language constructs, so is it a class or a field or anything else? And I will give you 2 seconds to think about that. And I will explain. So these target implementations are actually properties. So this is the type of the property, and target itself is a delegate. The first part of this here is just an expression-bodied body. And right after comes the delegate. So I know a couple of folks complain about that, but I can assure you after some time you really don't need to care about it, because for the different IDEs, so not even just with Rider or ReSharper, but also with VS Code and just plain old Visual Studio, we can just type n-target for NUKE target, and it will complete for us and ask for the name, and we can call it foo, and then just tap and jump into the executes delegate. So what we write here will actually be outputted. So I could write hello world right here. And now if I switch back to the console, I can type NUKE and then call foo. And then we should see foo being printed. So, or hello world being printed. Okay, so the next big advantage is, since it's a console application, I can very, very easily debug that as well. So let's also add the configuration right here. And the configuration already exists. And now I could, not through that, but I could move to the static int main here and call, I have to redefine it to foo. And then say I want to debug this project. And then I should actually stop at the breakpoint. Right here. And I can inspect my variables or my properties and fields. In this case, I can see configuration as debug. I can actually also inspect the whole build object. So the instance of this build class. Then I can see there are a couple of targets, the configuration right here. So it's very easy overall. All of that is possible without any further IDE plugins. There are, however, some plugins, and they will allow you to execute the build much more easy. So for instance, if I was about to implement this foo target and I want to run it over and over again, then in Rider and ReSharper, what I can do is to just hit Alt-Enter and then select foo, and it would execute foo. I can also move to the right and then say I want to debug it, or I want to run debug without dependencies. So just suppose we are implementing the compile target, which is dependent on the restore target, but restore takes a while, then we don't want to execute restore over and over again, but we want to jump right into compile. The same, by the way, can also be achieved from the command line. I would just do NUKE compile and then -- skip, and I can complete restore at this point as well. That would have the same effect. So I need to mention that for this, that was too soon. I want to mention that for this, I actually not even care just about ReSharper and Rider users, but also Visual Studio and VS Code. So in Visual Studio, this will look roughly like here. We have a tool window, which allows us to select a target and then decide if we want to attach the build process or skip dependencies, and it would be roughly the same. And for VS Code, it looks like that. We have a command for the command palette, but we also have code lens items above the target declarations from which we can run and debug our target. So I'm very sorry. I meanwhile also look at the stream, and it seems sometimes there are some artifacts, but I don't really know what to do about it. And if something is really messed up, then like it again, please tell me. Okay, that was it so far about the setup. And from now on, I will switch back to the Playground project, because the Playground project is really nice to show a couple of things that NUKE does well. So we will start with the target model. And the target model is just a sample build project, which, let me navigate again, target model here. And let me also quickly disable code vision so that we have a bit more space. Okay, so these are a couple of individual build projects. So in your case, it won't look like that, but for the sake of the playground, repository, I structured it like this. So with the target model build project, I want to show you how you can put things in relation to each other. And the first thing we do here is to execute nuke --plan. That's the wrong directory. So here, nuke --plan. And that unfortunately opened the plan on my second screen. So give me a second to move this somewhere else. Okay, let's go here. Let's try again here. Okay, so I really hope you can see this now. But now I have a full graph visualized that shows me how targets are related to each other. So at the very beginning, compile and restore are highlighted without any hovering, because those are compile is the default target and compile depends on restore. The second is I also have a unit test target. So if I execute that, then it will depend on compile and restore. The tests target depends on both integration tests and unit tests. So I will have that chain executed. You see that clean has a small dashed line, because in this case, I'm not expressing that clean is dependent for restore. So it's not a hard dependency, I like to call them. But you should rather picture it as if clean is executed in a schedule with restore, then clean should be scheduled before restore. So it's not that restore always requires clean to be executed, but if it's executed, then it should be before. And this will allow us to, for instance, define dependencies that, for instance, when I execute publish, that only then clean is executed. So publish depends on clean. But I also can make sure that clean is scheduled before restore. Also, in this case, publish triggers announce. I like to express it this way. So NUKE also provides provides an API to specify triggers. And in conventional build systems, I guess you would express that by having an announced target and letting it depend on the published target. But if you ask me, then calling the published target is much more meaningful than calling announce. So that's a bit of a semantic issue that I would have with solving it this way. And now I can go back to the actual implementation of my targets. So we can see we have clean. For clean, we can define that it should be before restore. That's what we have seen. I can actually also remove that. Let's try this again. I can actually also remove that and specify the dependency here and say after clean. But this is really a matter of taste. So I look at my targets as individual and how to say, let's put it this way, to be a bit encapsulated. So restore shouldn't necessarily know about the clean target, but the other way around. And NUKE allows you whatever kind of dependency, if it's a hard dependency or a soft ordering dependency or a trigger, it allows you to define dependencies from both sides. So as you wish, basically. Then we can also see, let's scroll a bit further, that, for instance, tests defines that it's dependent on compile, and that when it's skipped, that it should also skip its dependencies. So what that means is that if I have, for instance, let's say I'm executing the publish command and I want to skip all the tests, then I can say skip tests, and it should not execute the integration and unit tests. And it wants the API key from me. That's something I will show you later. But here we can see clean was would have been executed. Restore would have been executed, compile, but not the testing part. But otherwise, we would have run all of the rest. So the reason why this failed, I will show you in a second. Then I also have, for other targets like update changelog, I can define conditions. So that, for instance, with the update changelog, this target should only be executed if I'm actually on a release or hotfix branch. I can define a condition just like that. And the reason why the previous build failed is that we can also define requirements for our targets. So, for instance, that is a little bit of information I will talk about later about parameters. But API key is actually a parameter that I need for my publish implementation. So let's suppose you want to push your packages to NUKE, then we need the API key. And locally, NUKE would ask me about the API key, because locally I can still provide it, right? So this is some kind of interactive mode, you could call it. But if I kind of fake that I'm on a different environment, on a different host, like for instance Azure Pipelines, then we will see that the build immediately fails. And we can also see, so first off, we can see target publish requires member API key to be not null. And we can also see that none of our targets has been executed. None of them has been run. And the major benefit here is that just suppose that many of the other targets that are executed before publish take a lot of time. Then for sure you don't want to notice, or you don't want to be informed only when the publish target fails, although we could have said that right away. So this is very important to have this fast fail behavior and that we don't waste a lot of time. So if the rest I will talk about a bit later. But for the announce, I said in this case, I wanted to express it through a trigger and not through a normal dependency. So in this case, I can just call it triggered by publish. And one more thing here, and I actually forgot to mention this earlier, those Fluent API methods integrate very nicely with existing IDE tooling. So since this triggered by method expects let's see, an array of targets, I can actually use code completion. No, that's the emoji completion. I can actually code complete and get all the, well, meaningful values that make sense at this point. Okay, and then furthermore, if I have the publish target, then I can also rename from here. So for instance, if I want to call it publish NUGET, then this reference right here will also be updated. And I also have navigation. So for instance, build.publish. I can just type it like that, and I will be served with proper navigation inside my build. Okay, so next part, let's switch to my roadmap here, are parameters. Parameters. And now we can see the first time how parameters are actually defined. We just write a field, a basic field, and it's a private field, but it doesn't really matter. And we put an attribute called parameter on it. And this will result, if let me also navigate to this directory, parameters. Defining parameters will, just by writing a declaration like that, will make it into the help text of NUKE. So right here we can see it provides parameters, array param, bool param, enum, etc. And we can also define a description. The description would be put just here as a constructor argument. That would be the description. But other than that, I can also complete on the command line again. So if I type st for string param, it will complete to that. And it will also use this, I think it's called Lisp case format of parameter names. And then I can pass a parameter like hello Swiss
Matthias?
or hello world again. Yes?
You have now artifacts again. So if you just resize it, it will fix itself. So every time you basically zoom out and zoom back in, it's fixes itself.
Okay, I hope this will do. Okay. Yeah, should be. Okay, thanks. So I typed hello world for the string param, or let me just execute the build. And we have a target called print, and this will basically just print the values for our parameters that we have passed. So string param is null, bool param is null, enum param has basically the default value of the enumeration. So in this case, URI, the default is relative or absolute, and the array. And now let's pass some values with that. So I will do string param and say hello world. I will do bool param, and I could say true or false. But if I want to express that it's true, it's also enough to just use it as some kind of command line switch. So that is enough already. Now the enum parameter, again, I have the luxury of completing using tab completion or shell completion. And now, last but not least, the array param. And let's see, array param in this case is an array of strings. And we can use the plus sign as a separator. By default, I think the default is just a space. So we can also have an int array, then we just separate them with space. But for this, I can just type, let's do hello world again. I think that should do. Oh, what did I do? I forgot to add the closing quote. So let's do this. And not exactly. I think my console is a bit messed up. So sorry for that. So let's do this again. Hello world, bool param, enum param, absolute. So sometimes I have even artifacts locally. And array param, and we had hello world. Okay. So I missed the closing quotes before. Now we can see string value is hello world, bool param is true, enum absolute, and this has been separated just with a comma. Before I had a plus sign, but here you can see I'm joining the array params with comma. So that's it for parameters. Let's switch back. Let's switch back to our roadmap. And path construction is the next thing. So I suppose everyone has been in a situation where you work with your build infrastructure, and you either deal with a tool that one time understands understands that on Windows you're using just slashes, or the other way around. So yeah, based on the fact that you might have used the wrong path separators, / or /. And other times you might deal with a relative path, but suddenly you switch the working directory and your invocation doesn't work anymore. So with NUKE, I followed the approach that that we should use absolute paths whenever it's possible. And one property that the build class, the NUKE build base class, provides is the root directory. And the root directory, we can see it's of type absolute path, and it marks the root directory for our build execution. So what that means in other words is that for this project, for the playground project, the actual root directory is right here at up to this point. Why? Because at this point, we can also see there's the Git directory, but the Git directory is not the point here, just a coincidence basically, or generally recommended way. But the NUKE file exists there, and the NUKE file is currently just a marker file and also holds the default solution in it, and yeah, basically marks the root directory. And now let's switch back to our, no, that's the wrong one, to path construction. Path construction. And with the root directory, we can actually very easily construct other paths. So first off, if I just write normal and then root directory, that will be the absolute path to my root directory. Now, NUKE follows an approach using the division operator to kind of mimic the path separator. So this is kind of the same as using path combine and then root directory and then yeah, whatever path you want to concatenate. I don't even know if it supports walking upwards and all that stuff. I'm not sure. But anyway, NUKE is following that approach. But even though we are defining, some kind of, not normalized path here, NUKE will do this internally. So if I execute that, then we will see that for the division operator, we have proper absolute paths. And the benefit here, and I can't show that in the presentation, but if I was at a Windows system, then I would use the other kind of path separation. So this is something we abstract so that you don't have to worry about it. Another thing we can do with that is we can use globbing patterns. So from here, I'm working upwards the root directory, and I'm gathering all the test directories. And this is basically a globbing pattern, a very, very common practice with build automation. And then we'll just output that, and the same with the test directories. But in this case, I can also get the Windows relative path. So there's also a get Unix relative path. But just in case, sometimes you might need a Windows relative path or Unix relative path instead of the absolute path. So you can do this just like that. So we can see here first we have the absolute paths to the test directories, and right after we have the relative paths to them. Let me quickly get some water. Okay. Yeah, so that's it about the path construction. Very simple feature, but very, very helpful as well. The next thing I want to talk about is the solution model. So I do know that the .NET CLI allows us to add projects to a solution, but this is next level, I can promise you. So first off, and you will see a couple of different examples that that will implement the same but in different ways. Just to see how you can actually do it. I rather prefer some kind of this playground project instead of documentation that runs out of sync faster, I guess. So right here we have another field called solution of type solution and attributed with solution. So it looks very, very interesting if you remove the read-only modifier. But read-only would ensure that it's not modified during build execution. And so what that solution attribute here does is to initialize the solution object with a model that reflects our solution. So our NUKE dash playground solution is accessible through that object. And I can show you, for instance, via attributes, a very simple target, but let's invoke that. Let's go to solution model, and I will invoke via attributes. Oh, that was too fast. NUKE via attributes. So all that do is to print the absolute path to the solution. So you can also pass it as a string if you want to. Other than that, this build project also implements some kind of parsing. So again, we have the solution object, and let's gather all the test projects that match this pattern right here. And we will output them. And also we will output all the solution folders for that solution. So if we invoke that, NUKE parsing, let's scroll up. I should actually make this a little bit bigger, right? Sorry. Let me do this again. I'm really sorry about the artifacts, but it's very hard to also foresee because I can only see the stream a couple of seconds later. But yeah, I hope it kind of works. So in this case, we have printed the test projects, again, the absolute path for that, and then we can see the 3 solution folders that this solution has. This is not the only thing we can do. We can also do modifications. And in this case, I will just add a simple project, non-existent, with a certain path, which also doesn't exist. But anyway, I will add it to the solution. And I could also, if I want to, I could also pass the solution folder that it should belong to. But then I would first need to grab it etc. So in this case, it will add the project on the root level. But let me just execute that now. I will do NUKE, not parsing, but modifications. And then again, in writer, it's always the case that only after I unfocus the terminal, it will reload. But now we can see the non-existent target. Of course, it failed to load, but you could also use, of course, an existing target. It's just for the sake of demonstration in this case. And you can do a lot of other things. You can also create new solutions. I'm using this implementation to generate a global solution. So what I mean by global solution is that NUKE consists of a lot of different repositories, but I want to have one single solution where all the projects are located in. And that allows me to do cross repository refactorings. So that's a very nice approach. Probably not everyone needs that, but you can use this API to actually do something like that. So the third is tool invocation. The fifth already, sorry. The fifth is tool invocation. And for that, like I said, invoking command line tools is very central task in build automation. So in this case, I might want to execute the .NET CLI. And I can do this just by using string interpolation, for instance. I could do a .NET restore solution. That would be the equivalent of calling .NET restore and then my solution, whatever that is. String interpolation really comes in handy. We can see it here with a consecutive call. Because we even have two. Now, just for the matter of motivating my next step, let's suppose the -- no restore step is dependent from some other logic. Let's say we have a parameter. Yeah, Michael?
You cannot see what you have written after configuration. So the -- after configuration is the last thing you see.
Okay, I hope now it works.
No, now you can see it.
Yeah, okay. Yeah, so let's say this part of the invocation should be should depend upon some flag. So let's say no restore. We have a parameter no restore. Then what we could write is something like no restore, and then if so, then pass it. Otherwise, we have string empty, right? But this isn't really great. So first, we need to also have the brackets around that, parentheses around that. But this isn't really great. So I could extract it, but it's not great to read. In order to solve that, NUKE has a second way of invoking tools, which is the Fluent API. And so in this case, we have a different parameter here for ignore failed sources, but I guess you know where this is leading to. But in this case, I'm using a method called .NET restore, and then I have basically a builder pattern, which I can use to pass the solution and to define if the ignore failed source parameter should be added or not. So it's the ignore failed sources. This is controlled through this Boolean value, basically. We can look at some other examples, like .NET Build is also implemented that way. You have the project file, the solution, the configuration. For Boolean arguments, like in this case, we even can use enable or disable no restore, or toggle no restore, whatever you need. I never use toggle, but someone recently mentioned that he needed toggle. And we can also define values that belong to a closed set of values. So for instance, verbosity only accepts certain, parameters. So I can invoke code completion. It will show me those that are meaningful here. What we can see as well is if we invoke quick documentation, then this is this can be very helpful. And this is because this is the very same documentation that is written on the Microsoft official documentation website. So here, it's the very same as on the official website. The official website is also linked here. And we can also see here are some remarks about the Fluent API, what kind of values we can modify through the Fluent API. The Fluent API is actually, I think I will skip the generation part, but the Fluent API is generated. So it's not handwritten or something, but really generated from some other source of information. It really depends on what tool we support. But I want to explain very shortly how we do it. So for instance, can I maybe, I could open the actual project of NUKE, new window. So where is it? Here. So Docker has a similar API, but it is generated from a JSON file. And the JSON file is quite large, but it has all the information. Like here we can see there is a property called input. It is of type string, and it should be outputted as that, and that is the help text. Now, even the Docker JSON file is quite large. So we can see down here, it's almost 10,000 lines of code. And if I look into the generated API, that is even, let's see. That is even, I forgot the shortcut. That's 80,000 lines of code implementing that Fluent API. That is compiled into NUKE as a library. But for you as a user of NUKE, this is very approachable. And even without internet connection or something, you could actually take a look into some documentation, read about things and what they mean without needing to worry. All right, I need to switch my solution again. So there's one other advantage that this approach has. And that is, for instance, enabling coverage will not only influence a single parameter that we pass, but a couple of them. And that we can see here, because with the Fluent API, I can say only when enable coverage is true, only then enable collect coverage, set the coverlet output format. And in addition, this is like a nested if statement, enable source link if we are on the server. So on the server means executing on Azure pipelines, GitHub Actions, etc. Another example where this comes in really handy is if we have projects that, or if we have an invocation for different projects which looks roughly the same. So for instance, in this case, let's say I want to execute .NET Publish first library, configuration, release, and what else? Framework, NetCore app 2.0. Now imagine I also want to do this for 3.0, and I also want to do it for the second library. Then traditionally we could use for eaches, of course, but NUKE provides a better way, and that is through the combine with method. The combine with method takes an enumerable of combinations. The combinations have been produced here. We first get all the projects of our solution with and with Rary. Then for each of them, we get all the frameworks or the target frameworks, and then we create some kind of parameter pair. This very same enumerable is then iterated, and for each and every call, we can set the project and framework. So this is invoked like 3 times in this case. And NUKE will take care and execute them one by one. Now you might ask, why one by one? Maybe I want to execute them concurrently, right? Which is a fair use case, sure, especially if you want to publish packages. Because in that case, you might want to publish all the packages. Let's say you have 10 and you always want to send 5 concurrently. And yes, there was the question about the NUKE for VS Code. No, I have no idea if there's one for VS Code. But yeah, for IDE it exists. Probably there is something for VS Code. Anyway, get back to the packages. I can actually do that. And that is up until here, it's the very same as I have explained before. And then we can define we want to have a degree of parallelism of 5. And we also want to express that it should complete on failure. Now, what do I mean by that? With NUGET packages, it's sometimes, I actually never had the case, but sometimes it might happen that only one of your packages has not been pushed because the connection broke or something. Then if you re-invoke the push command, then of course you don't want to modify it and make something like a where command and only take the one that is missing, but you want to execute the pushing of all the packages again, and those that exist already, they can just fail, but you're really interested to get the one that was missing pushed. So this can be expressed with complete on failure. And it's not bound to the .NET NuGet push command. It works with any tool that is supported with NUKE. And regarding that, I can also show you there's quite a bunch of tools that we I will show you. I will show it here. There's quite a bunch of tools that we support. So here on the left, you can see Azure GitLink, GitHub, dubfinder.net, .cover, etc., Twitter, VS Test, Octopus, NUnit, basically everything you need. And actually, and I think that's really interesting, the amount of lines of code generated in NUKE are approximately 250,000 lines of code. Yes, SonarQube is supported as well, and many people use it. So that's it for the. Sorry, I need to switch back here. I think that's it for the Fluent API part. There is also a lightweight approach. So for instance, for Git, we can just load the Git executable from the path. So that's why it's called path executable. And this way I can use Git as some kind of a method, basically. I can call Git as a method. And I can also define not only the arguments, but also the working directory, the environment variables. I can see all that we can see here. But we can also load executables from packages from the global NuGet package cache, or locally if we really have to commit an executable with our repository, then we can do this as well. Okay, the next thing is CI configuration. I will probably skip tool generation because, or maybe at the end, but for now, CI configuration. So at the beginning, I mentioned that build servers have the advantage of executing builds in parallel and using queue optimization. However, with conventional build automation systems like Cake and Fake, at least to my knowledge, I must add, they rely on the fact that they have a very small CI configuration file, like for AppWare or or GitHub Actions or like, and they just pass the execution to the build system, and that's all. And while this is of course possible, it also at the same time it kind of takes the advantages from us that we can gain with build servers, because then we only have a very sequential execution of our build. What NUKE does, and also for the sake of keeping you sane and not having you to write YAML files, is to generate those files for you. Let's switch back to CI configurations. So in this case, I again have a very simple implementation of my build. I have a compile target, a pack target, publish, and let's minimize that here for a second. And I have a test target. And then inside, and I have different versions of that. I have, for instance, an adware attribute. So this is the same build class, it's just defined partial, so that we can focus on the part that's written here. So in this case, I have the adware attribute, and I'm going to tell adware that it should build Ubuntu latest and Visual Studio latest. Those are the images. I can also complete here with Koch completion. And right after, I tell what target should be invoked. So in this case, it's the test
Matthias,
target.
The sound is breaking up.
I will rejoin, okay?
Yes.
I hope that works. Let's see. Is it really bad?
Yeah, really, really bad. Can't hear you.
Okay, let me try to read.
Just a second. Hope that Matthias gets his audio worked out. So let's give him 2 minutes. Yeah, and
Okay, hello. Can you hear me again?
Yes, now your sound is okay again.
Okay, and I'm so sorry for that, but it's really
No worry, you're holding up very good.
Okay, I will continue. And thanks, Michael. So for the invoke targets, what's really interesting here is that we can make use of the name of operator, and we can actually, if we had mistyped our parameter here, it would show up, and we can also rename the target from here, the test property. Okay, but what will that do actually? Let's move to the directory, and now for this CI configuration to be generated, all that I have to do is to execute NUKE one time, and it doesn't matter what command I'm invoking, but help is the most no-op command that I can think of. So what happened now is that if I look at the file system view, I have an adware file generated. I can also see it's marked as generated, and I have the image and the build script, which is invoked with the test target. That doesn't look so impressive, I know. But we can continue maybe with another of those. So let's continue with GitHub Actions maybe. In this case, again, I have to give it a name. I have the 2 images that I want to build on, and I have the triggers. So in this case, I also have code completion, because I can either build on push or pull request. And again, the invoke target. So that's it works roughly the same, but I have a different file, of course. This looks a bit bigger already. I have the Ubuntu job and the Windows latest job, and that will execute then. Now it gets interesting, because we will look at Azure pipelines. For Azure pipelines, this is basically the same, but the invoke targets is also the same, but we will mark compile as non-entry targets. And that means, I need to explain a bit more up front, I think. This build graph using a set of build agents would allow us to execute targets on individual build agents. But with NUKE, we can actually, for at least in this example, I want to execute them still on the same agent. So that's why I say target with dedicated agent execution. So compile won't be executed on a separate agent. So the Azure pipelines file is quite big already, or even bigger. I should have continued with TeamCity already right away, because with TeamCity, the attribute looks almost the same again. I will just show you this part in action. Maybe that's a better approach. So TeamCity, this is my TeamCity interface for NUKE, for the NUKE project. And I can see that test, pack, coverage, publish are all different and dedicated build configurations. So they will run on individual agents. And this also allows, we can see that test is separated into 1 and 2, and this happens automatically. Or almost automatically, I will show you in a second. But other than that, each and every build target will have its dedicated build agent. And we can make actual use of parallelization. So for the parallelization of targets in particular here, what we have to do is to define a partition. And in NUKE, that is done with roughly 3 lines of code, actually. So first, we will create a partition. That's here. And we call it test partition because it will be used for the test target. We also divide it into 3 different partitions. And then we have a property which, if we wouldn't have used partitioning, then first it would look like this. Test projects, and we just get all the test projects from our solution. But with the partition, I would just call from the test partition, get current. And since the test partition object will be different on each and every build agent, so on the first agent, the partition object will reflect this information. On the second, it will be this information. On the third, this. Since we do that, each and every partition will just use the test projects assigned to them. And other than that, we just need to assign the partition to the test project, and that's it. That's all we have to do to gain the advantage of having test targets executed in parallel. That is also supported for Azure pipelines. So here we can also see, let's move down. So here, those will also execute in parallel. We can see, I can't select text here, unfortunately. But we are here in this view. We can see it. We have the Ubuntu latest job with 4 steps. Those will execute concurrently or in parallel. And yeah, so that's it for the CI configuration. And then, unfortunately, really, I will just focus on one more thing for build sharing. Unfortunately, time runs a bit out. I think, what did I say when I want to stop? I think at 15. Yeah. Okay, so I will just quickly try to show you a very new thing and very interesting thing, actually. NUKE now makes use of default interface implementation, and that allows us to, that's a C#8 feature, and that allows us to compose our build out of different predefined targets. So for instance, I could have an I solution which holds a solution object already. Then I have an interface which implements the build. And it introduces another configuration parameter, inherits from I has solution, I get versioned, and then would define 2 targets. Then furthermore, I have, let's say, I publish NuGet interface, which is based on those 2. And I has package output. I has package output has just an output directory property that we actually need to implement in our class. But other than that, we just have 2 other targets. And now in our build implementation, we just inherit from that, and we could add some more sugar, like a clean target, a validate packages target, an announce target, and we can still put those into relation. So I can still say clean should be before the restore target, which is inherited from iBuild. It should be dependent for the publish target defined in iPublish NuGet, etc. And this is all based on the idea of default interface implementations. And that is a very great way, I would say, to implement a build once and use it in different projects. So you could have your own base build NuGet package, let's say, and then just compose it out of different ingredients or everything you want, and it's very easy, basically. Okay, there is also, and I will just mention that briefly, there is also the possibility to register a NUKE build as some kind of global tool. And I've done this in this case already. So if we look into the CS project file of that, it is registered as build command. And that's very easy because the installation is here in a partial file. But other than that, this is the default target. And now I have a build command that prints in any directory I am. It will print the current directory, the number of directories, and the number of files. So if I navigate here and I type build in global tool, then I can see it's, it prints the current directory. If I move upwards, again, prints the current directory. And here they are a bit different. But yeah, basically you can provide targets which can be shipped just as a ready-to-go executable. Okay, I will stop at this point. Unfortunately, I haven't finished everything, but I really recommend you to wait. What do I recommend you? To go to our repository, maybe put a star on it if you like it, but you can also join the Slack workspace and follow on Twitter. And other than that, I'm finished with my presentation. I thank you very much for...
There's one question, I think. Just let me read it. Is it planned to integrate local CLI tools natively, like NUKE works with NuGet packages? So let me...
I'm not sure what that means. Local CLI tools natively. What is a local CLI tool?
Basically, the .NET, when you type .NET and there's the CLI tool. That's basically Microsoft's integration into the .NET CLI. I guess that's what it means.
The local, something like the .NET entity framework, for instance.
Yes, exactly that.
Yeah, so it really depends. If the tool is mature enough, there have been several PRs already which have added support for individual commands. So entity framework, for instance, is supported already, but the .NET CLI itself already, I mean, what's there already supports a bunch of things like .NET build, clean, pack, publish, restore, run, test, tool install, tool uninstall, tool update, etc. But using this generation approach, it is really easy to add support for that.
But I think what this question actually is about is I just guess it from the comment there, because the user might just like how you can set up new NUKE targets, and basically you could use it. Oh, there is a, for example, .NET Sonar scanner. Now I get it. So I think that is already integrated. So you can take NUKE, and then Matthias already built integrations into Sonar. So you just can plug in Sonar into NUKE and use it natively in the targets. And that was also one of my initial questions. And I know Sonar is a pain to use on the console with lots of undocumented properties. So, and I just spotted when Matthias went through his integrations, there was a Sonar scanner integration.
Yeah, and this is actually also the big benefit. Some tools only have very simple parameters like -s, and you have no idea what they actually mean. But through the interface that NUKE provides, you will see that. Like for instance, I think sign tool task, for instance, has some of those, if I remember correctly. And so you see, if I invoke the quick documentation from here, you can see /a is modified through automatic selection, and those are much more readable, and you immediately know what they mean, as opposed to you're using this /s, which is, for a novice, at least for a novice, it won't say anything. Whereas append signature already gives some idea what this actually is. Okay.
Yeah.
That's it with the question, I guess.
Yes, I think the other ones you answered already while you were talking.
Okay, good. Okay, let me quickly move to the... I will enable webcams again, at least for you, okay?
Yes.
I will add Matt now. And I will add...
Just before we get on, for all the users listening, you have now time to get a new drink. So we do 5 minutes pause before Matt is up. So we'll start, or let's do 3. So we start at 25 past 7 with Matt's talk.
Okay. Yeah, thanks. I almost forgot about that. There should be a break, yeah, even for me.
I thought you meant you'd forgotten about my talk.
No,
I
I also posted the YouTube link of Matthias.next talk, but mentioned below that please don't leave yet, because we have another great speaker coming up.
And this time without artifacts and sound issues. I mean, it's. I want to really congratulate Matthias. He endured it like a champ here. That was simply amazing. If it was me, I would be already getting the keyboard, like
Thanks.
hitting that on the first artifact. But you got not only the vertical at the beginning, but then an horizontal one, and then you started with the sound issues. So honestly, what can go wrong? It went wrong, and you endure it.
Yeah, thanks very much. Yeah, actually, I just got the opportunity to be the first, since I managed it this time. If I'm honest, Matt's talk is way more interesting and more broad. How do you say, not broad, but for the general public, meaningful talk. So that's something I should mention.
Yeah,
you say very nice things there, but I'm just hoping that you've ironed out all the technical difficulties for me and took one for the team there, which is very nice of you.
Yeah, I actually saw it at NEC London. It was a great talk.
Thank you.
If it's the same, but the title is the same.
yes, it's basically the same talk. Yeah.
All the bugs are already used, so probably it will go fine, Matt.
Yeah.
We'll see.
Yeah, so for the people listening, and if you want to rewatch Matthias' talk, there is a .next recording of it. I posted the link in the YouTube chat, or just Google for .next Matthias Koch, and you will find artifact-free version of his talk.
I'm so sorry, but I have to say that's not the best way. So on
Okay.
so on nuke.build, so I actually got that domain. There are a couple of talks linked. The .next talk is one of the oldest, I think. Unfortunately, so many things have been implemented since then. But I really recommend nuke.build. Will have a resource section, and that provides all the presentations that I have been given. By the way, Matt, you maybe can share your screen already. And Jose, this time I will leave you in the broadcast, all right? And I will remove myself and Michael.
Sounds good.
Yeah? Okay. Matt, are you sharing already? He's frozen on my side.
Okay.
On my side too.
Me too. So I think he's frozen. Out.
Yeah,
Let's hope for the best.
Yeah, in the meantime, we can do some small talk. No worries.
Well, it's truth and Murphy lives, right? And there is no one issue without another one, at least.
Yeah. I can see Matt again. You're
Matt,
unfrozen.
Yep. You can share your screen if you like.
Okay, I'm just trying to just.
Cool.
You can also, if you experience more issues, I've also disabled just my camera to be sure.
Yeah, well, I will do now mine.
Me too.
Okay, I'm sharing the screen. How's that looking? Ah, look at that. Let's press play.
Okay, it's you can hear me, yeah? Yes, it's there.
Yeah.
And do you prefer do you want to leave the webcam on or off?
I might as well leave it on because I got quite a few slides, and otherwise it'll just be a picture of slides. You can actually see me talking the other way.
Okay. All right. I remove myself and then listen for your talk as well.
Okay, good stuff. If there are problems with artifacts in this one, please let me know as well, because some of the slides could well be covered. So shout out if you can't see what's going on the screen. So hi, everybody. So this is, as Michael says, a talk I've given a few times before. I like this talk. I think it's an interesting one. It's quite a relevant talk, I think, as well, because it kind of fits in a lot with some of the trends that have been happening in C# over the last year or two, really, and sort of change of focus, I think, with how C# in the .NET world is changing. We've kind of been very used to having C# do a lot of work for us, being a very sort of managed environment that we can use, and there's been a change in emphasis to make it very much about performance and about making the code you write as performant as possible. So this talk is basically, it's kind of a bit of a performance type talk there. It's about writing allocation-free code in C#. And before we go any further, really, I think a bit of word of advice really is the simple answer is don't do this. Don't do this. The point is, the things I'm going to show you really are micro optimizations, and basically you don't need to do this. This is a whole bunch of stuff that on the whole you won't need to do, so don't really change your way you code and all that to do this, unless you actually do need to do this. And this is really the key part of the whole talk. And if you take anything away from this session, really, it's this. Always be measuring. Always make sure you profile your code. Don't change stuff just to change it. Change it because it needs changing, because there's actually a performance problem, and you can only really do that and know that by measuring and by profiling. So, okay, why am I talking about allocation-free code and sort of writing that and the changing the style and the performance and all that kind of stuff? Well, we have traditionally sort of learned that sort of C# and the managed environment we live in, sort of managed memory is basically cheap. That's kind of the idea that we've got there, and that's not quite right, really. Allocation is cheap. And so it's very easy to allocate memory. In some circumstances, it's literally just moving a pointer. But basically, it's not just that allocation is cheap. The flip side to that is that garbage collection is expensive. When you're doing garbage collection, it might be very easy to allocate memory, but when you're done with it, the garbage collector needs to basically freeze the world, stop all your threads, stop execution, go through all your objects in memory, mark the ones that are in use, that are not in use, get rid of them, and then compact the heaps there. And it's got a lot of work to be doing, and so garbage collection itself can be quite expensive. And so we kind of want to avoid garbage collection if we can. And really what we're aiming for here is throughput. It's not necessarily about reducing the peak memory, so the amount of memory you're using at any one time, but the throughput, the amount of memory traffic you're doing. So what do I mean by that? So the idea really is that more allocations mean more garbage collections, and more garbage collections introduce pauses, and pauses disrupt your throughput. So this isn't necessarily about making your code faster, but more about, say, making it smoother. So you're having fewer interruptions, fewer pauses, fewer sort of noticeable lags, as it were, in your execution. And better throughput, really, it's good for low latency stuff. So that's kind of servers, web servers, games, interactive user interface, and so on. When you look at it like that, that kind of covers a lot of what we do. A lot of web sort of stuff there. Gaming technology, obviously, we want those to be very responsive. And the same with your user interface. You want that to be responsive all the time as best you can. And that basically doesn't leave very much other than sort of batch processes. And you probably still want your compiler to run quickly as well. Just as an example of what I mean here with kind of throughput, recently Rider introduced a feature called dynamic program analysis, which is it's a really cool feature, actually. It's essentially profiling continuously. And every time you run your application there, it's doing a very lightweight bit of profiling going on there and capturing common problems, common issues, and it'll sort of flag up things like memory allocation. And so I've got a tweet here. I've taken the name off, actually, because I forgot to ask permission. But a tweet we had, which is brilliant. Somebody using the dynamic program analysis realized that at startup, they were allocating 13 gigabytes during application start. And this doesn't necessarily mean that all of a sudden their memory usage went up to 13 gigabytes, but over the life cycle of the application start, they used up 13 gigabytes. That's 13 gigabytes worth of work that was happening basically because of a toString instead of parsing an int that didn't need to happen. And reducing that is going to help you definitely with things like garbage collection, which will have had to kick in to help clear up some of that. Other reasons why this is useful as well is that you're going to be working in a constrained environment. So you could be working on a mobile device or working in a sort of mobile device like your phone, for example, tablets, consoles as well. So if you're doing gaming with something like Unity, you can be running that on a game console. Containers as well for distribution to the cloud, and a whole load of places where you could be running in an environment with constrained resources. And basically, using less memory is a good thing in these circumstances. And if you're working on a device as well, this device might be, such as a mobile device, it might be less powerful as well. So your garbage collections could be slower, which could then, exaggerate really the impact of garbage collections and throughput. And of course, fewer garbage collections is going to be better for battery because the less work you do, the better. It's great. So it all does boil down to throughput. And again, just pointing out things like mobile gaming is a big deal in this. So half of the games that you've got on your mobile device, whichever operating system it is, Android or iPhone or whatever, they're built on Unity, and Unity is a C# environment. It's running mono. So avoiding, these kind of situations where you're avoiding garbage collection and so on are going to be very useful. And there's another reason as well, which I like. And I think it's basically know your platform. You should know the environment you're working in. And even if you're not sort of specifically using any of these things, which I'm going to be talking about, you're still going to be using it because it's part of the platform. So it's very useful to make sure that you understand what's going on under the covers, maybe just one layer down, and so you know what's going on. And that's really sort of important because, as I say, over the last year or two, the focus has changed a lot in both the sort of the C# compiler and the .NET platform itself, the .NET Core and so on. The performance has really become a key part of the design. So a good example is with the C# tuples, or tuples, depending on how you want to pronounce it. The .NET Framework already has a tuple type, but it's a class. And to get a better performance characteristic out of C# tuples, they've introduced a new type, which is a value type, which is a struct. And that's work there. So even though there was a type existing there, the focus is more on the performance side of things, and it'll introduce a new type to work with that. There's a similar thing with value task as well. So we're all familiar with task of T and task there in the threading library there. There's also now a value task, which is a value type in which solves a number of problems there, and that's useful in both async await, but also in the new async enumerator work for the await for each and so on, the async streams. And then, of course, there's a span of T and slicing, which I'll cover shortly. Okay, so what are the things we can do here? How can we avoid allocating memory to make things a little bit easier? Well, there's some low-hanging fruit, as it were, some easy things we can do, some of the known sort of things we can do. There's a bunch of things here. So, for example, object reuse. So we can use an existing array rather than allocating a new one. We can pool objects as well. So we can pull an object out, use it, put it back, reset it back to defaults, and pull it back and reuse it so that we don't have to keep on allocating the same objects. String concatenation is a clear favorite. Everybody kind of knows, really, instead of just doing plus, 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 we can use string builders. And we can pre-allocate the length there as well. So if we know that the string we're going to be building is going to be 10K long, 20K, 3 megabytes, whatever, we can pre-allocate that so it doesn't have to allocate, reallocate, and reallocate again. And of course, we can object pool these as well. So we've got a string builder with a nice, decent length already allocated in it, stash it away for a bit, and reuse it if necessary. Params is a good one. It's an interesting one, actually. So let's have a look at that one in a bit more detail. This one is interesting because it is more about an unexpected compiler generation, an unexpected compiler generated allocations. So you can see your C# code, and there's no allocations visible there. But when it gets compiled, the compiler actually inserts allocations for you. So you've got your params argument here, which takes in a string array. But because we're using the params keyword, we can write it just as 2 values. But when it gets compiled, the compiler actually generates an array for you, and it's going to allocate at runtime an array of those 2 values, and it'll allocate it every single time you're calling the method. But what's even more interesting is if you've got an empty parameter list there, you're not passing anything, the compiler will still generate an array for you. It'll just generate an empty array. Sorry, it'll generate an allocation for you, and it'll allocate an empty array. So every single time you're calling that, you're not passing any methods in it, you're still allocating and passing that in. Except I've just lied to you. That's not strictly true. There's a problem there in that newer frameworks and compilers have changed how this works. And instead of allocating a new empty array every single time, we get to reuse a framework type, array.empty, which shares an empty array. And so it's a whole lot cheaper. So again, this is just to reinforce the point. You've got to be measuring this sort of thing. You don't want to just trust some guy on a web conference call. It's something which you need to check for yourself, and also things change. And so advice which is valid at one point is not necessarily valid a year or so down the line. Okay, so next thing to look at is boxing. So boxing is when you pass a value type to a method expecting a reference type. What happens here is that we create a new object on the heap, which is going to be the box that contains a copy of the value type, and then passes it along. Any changes you make to the box value don't affect the original, but you've still got an allocation going on there. And here we've got a small screenshot, which is Ryder showing, pointing out this allocation that's going on, this boxing that's happening here. This is a plugin called Heap Viewer, which tries to find some of these hidden compiler-generated allocations for you and highlight them, so at least you know that they're going on. But let's back up a little bit. So I'm just talking there about reference types and value types. Let's have a bit of a reminder of what they are and what they mean. So on the one hand, we've got reference types. These are allocated by, these are created with the class keyword. And on the other side, we've got value types with the struct keyword. And again, please shout out if there's artifacts here and it's harder to see. I'll try and explain everything that's on the screen, so we should see. But let me know if there are problems. So reference type, class keyword, it's something that's allocated on the heap. And a variable for reference type is a reference to that thing on the heap. And this is passed around by reference as well. So you pass in a reference there, and it's just pointing to the object on the heap. It's the same thing all the time. When you assign a value as a reference type, it's a copy of the reference, not the object. So you've got one object on the heap, and you're basically just referring to it in your code. Whereas value types, on the other hand, these are the struct keyword. They're allocated on the stack, or they're embedded inside a reference object. So if you've got a value type, which is a 3D point, for example, X, Y, Z, in there, it might be 3 values, floats, that can be embedded directly inside a reference object. So if you've got a spaceship object with a 3D point in it there, that 3D point is absolutely embedded directly in your reference object. The value type as well, if you have a variable which is a value type, it's not a reference to it somewhere else, it's the actual value itself. And this is passed around by value as well. So if you want to pass that to somewhere else, you get another copy of it, because as I say, a variable of a value type is the value itself. So another variable is a copy of the whole value. And this means very different characteristics. But then what do I mean by heap versus stack? I've been talking about this. Well, what's the difference here? So the heap is general purpose memory. It's something which lives, and it can be a very large amount of memory, and it lives and it's available for the lifetime of the application. Any allocation you make inside the heap can last for the whole lifetime of the application. It can last shorter than that, of course, if you don't need it any longer, but it has the potential to last for the lifetime of the whole application. Whereas the stack is a block of memory which is used for data which is required by methods. So every time you enter a method, the method itself reserves some space on the stack for local variables. And when it finishes, it pops that stack and clears everything up there. So stack allocation is purely for the lifetime of the method itself. It can't live longer than the method. And since value types the whole data, they live directly on the stack. So if you've got your stack of variables here and you've got a 3D point, it'll live and take up a piece of that memory there. Whereas a reference will actually still be a pointer effectively. It'll be a reference to somewhere in the heap. You can use the stack alloc keyword if you want to create a block of memory on the stack, although that's not very common. But the key thing here really with the stack is that allocation and cleanup is cheap on the stack, but you've got limited space. You can't allocate huge chunks of memory on the stack itself, and also it's of limited lifetime as well. All right, so back to that list of things we can do to improve and reduce the memory allocations that we've got there. Closures is a big one. Closures is a really useful way of writing code, having functions which capture information about the surrounding from the surrounding context. And these are really cool, but there's a cost to them. So the compiler will rewrite your code. It captures the local variable. So in this example here, it's capturing the name parameter from the function filter names. And it will create a new class, and it'll add that as a field on the class. And the lambda itself, the actual delegate we're passing in there, is actually rewritten as a method on the class. And so every time it's called, we have to create a new allocation of this class in order to capture the information. Link is a heavy user of closures as well. It's a great API. It's really useful. It's really a great way of working. But there's a cost to it. You've got it's very heavy with closures. You pass a lot of functions and actions around to it, and a lot of closures being created and captured and passed around. And on top of that, there's usually a static method allocated for the enumerator class itself, so you can return the values. And again, the heap allocation viewer plugin for Rider or ReSharper there can actually show this too. It can sort of call it out there, highlight where those allocations are occurring and what values are being allocated. Iterators, there's a kind of similar sort of thing going on here. Your code is rewritten behind the scenes. You get rewritten into a state machine. So you've got a compiler allocation going here where you allocate the state machine and then start to return the values back. And async await, again, a fantastic API, but you need to understand what the cost is. There's the code is again rewritten into a state machine, similar to iterators. So there's an allocation for the state machine, allocation for the task method builder that goes along with it, some sort of machine. Also got extra allocations for the task it returns back or the task of T there. And this can be expensive for common use cases for things like a asynchronous return. So if I'm calling an asynchronous method which already has the value, it can return it straight back, but there's an allocation happening there, perhaps unnecessarily. It's hard to reuse some of these values as well. And there are a number of sort of interesting problems there. One of the useful things here is the new value task. Well, I don't think it's that new, actually, looking at the date there. It's interesting how long these things have been around for, really, is the value task type, which is very useful for common use cases. And there's a great blog post there explaining some of why the value task has been introduced, what problems it's there to address, and when you'd want to use it. And I've got more links at the end of the slide deck here, so we can show those again. So that's basically some of our more obvious things we can have a look at there. So things like the params arguments there, we can mitigate that by introducing overloads with a common number of arguments. If you know that you're only going to call it with 1, 2, 3, or 4 arguments, you can create overloads and very easily work around that issue. So you can call it anywhere in your code with the same convenience as with the params arguments, but without actually having to introduce allocations. Boxing, you can do a similar sort of thing by introducing overloads, but you can use generic types there. Rather than passing, using object and passing things in as object and causing boxings, you can have generic methods themselves and let the runtime sort it all out for you. Closures, you probably want to avoid those in a critical path. If you're doing some code which is really critical, is going to get called a lot of times, very, very frequently, you probably want to avoid using a closure. Do you want to perhaps pass the state as arguments to a lambda? So rather than allowing the compiler to generate a class for you, you manage that state yourself and pass that in as an argument to the lambda. An interesting thing to look at here as well is local functions. Local functions are very similar in many respects to closures and lambdas. You can use it to capture information from the local environment, capture fields, variables, parameters, or whatever. But the difference is that on the whole, local functions will use structs. Won't necessarily use them every time, so it's useful to have a look in that and see how that will work out for you. But as I say, it's a good rule of thumb that on a really busy critical path, you want to avoid using closures. And a similar bit of advice really for LINQ as well. As I say, it's a great API. I really like it, but it can be expensive in a critical path, in a hot loop, in a really busy bit of code there. It's perhaps best to unroll the nice LINQ statements and use good old for each and if statements instead. Iterators is a little bit different. It's a little bit harder to provide some advice for, really. You could perhaps return a collection, but then you might have to allocate the collection, and maybe the iterator would have been lazy and just looked at a couple of items in the collection, whereas a collection itself could be allocating 10 times the number of items that are going on there. So it's hard to give some advice to what to do there, other than really be aware of the cost itself and measure it and see what would work in your particular scenario. And with async await, again, great API, investigate value task and the number of reductions that have been working on in the platform then to sort of improve that situation. So that's some of the sort of easier ones, I guess, to sort of sort out and fix with yourself. But I want to have a look at something a little bit more interesting. I want to have a look at the reference semantics with value types, which is a bit of a mouthful, it has to be said. It's a little bit tricky to understand what that means. And basically, it's a set of features which came about really in C# 7.2. Things like in parameters, ref locals and ref returns, ref read-only returns, read-only struct, and ref struct. That's really not very helpful in explaining what reference semantics for value types means there. So let's have a bit of a different look at this then. The idea with this is that allocating a reference type has a cost because of garbage collection, but passing it around is cheap. Passing things around by reference is very, very cheap, very easy. Allocating a value type is cheap because it's on the stack and it can get cleaned up very quickly, but passing it around has a cost because you're going to copy it. You're going to make copies, and once you're making a copy, you're no longer modifying the original value and so on. So that it's a bit tricky there. So why can't we have both? Why can't we be cheap to allocate and cheap to pass around? And that essentially is what our reference semantics with value types means. And basically, it means allowing us to treat value types like reference types. So we can pass things around by reference everywhere. So this is good because we can use value types to reduce our number of allocations, reduce the memory traffic and so on, and that's good for our throughput. We can avoid garbage collections and have a bit of a smoother experience. Pass by reference also means we can avoid copies, enable modifying as well, even when we're using value types and so on, and it can lead to a lot of very useful ways of working with your code. But again, this is very low-level micro-optimizations. You don't want to use these unless you really need to use them. But it's worth knowing what's going on there because they are used in the platform. And there are lots of scenarios actually where it will be useful as well. So gaming, again, would be a very useful one for that. Parsing is also going to be very useful. It'd be great to be able to pass data around while parsing without having to allocate lots of memory for the little parts of strings there themselves. So JSON files which don't use allocation would be great there. Serialization, also one there, and so on as well. There's going to be lots of different scenarios, opportunities. I can't think of the right word for where this is going to apply. But again, let's step back a little bit here. I've been talking about pass by reference and pass by value. What do I mean by this? So if you remember, I was saying a variable for a reference type is a reference to the actual object on the heap. So if I've got a variable for a reference type, this basically tells me that I've got something on my heap over there. Passing a reference type to another method is just passing the reference. The object's still living on the heap. I've just now got two ways of referring to the same object. The caller and the called method see the same object on the heap. So it's the same object all the time, and it's very easy to basically just tell the called method that it's just over there. Value types, the variable for a value type is the value itself. So if I've got my point, my x, y, z perhaps, then that value type is the value itself. Passing that to another method copies the value. So I've now got two copies of it, and assigning a value type to a new variable also copies the value as well. So it's just going to copy all over the place. The original value is unmodified, and any changes I make to any of these copies do not get reflected back in the original value. It's also important to point out that copies aren't actually that expensive. So if I am talking about a 3D point, I've got 3 float values, x, y, z, it's only 3 float values. So it's not a huge problem here. And again, we're talking about micro-optimizations and ways you can improve your code in small details. But if you're using a lot of floats, if you're doing this a lot of times in a hot path, 60 frames a second, for example, thinking of games, then it can have a big impact. Okay, so the first feature, which is interesting for all of this, is introduced in 7.0, actually C# 7.0, and that's a ref return. This allows us to return a reference to a value type rather than a copy of the value type. So if I'm returning back an integer from a method, I can actually return back an integer reference. So this changes the return type of the method. Until we had this feature, you can't see how that looks like in C#. We've got no way of representing it. But if you had a look at it in intermediate language, in the IL, you'd see that it's actually a different return type, int ampersand, as it's written in IL. So it is very much a different return type to just returning back an integer. This has an impact on the lifetime of that returned value. So it can't exceed the lifetime of the called method. So if I'm returning back a reference to an integer which lived inside a method, that's going to fail because I've got my stack of information here. If I've got my little variable inside the stack there, as soon as the method finishes, the stack goes away, and obviously that variable goes away, and so I can't return a reference to that variable. So a ref return has to be a reference to a field or a method argument, something that lives longer than the called method. For similar reasons then, because async methods get rewritten into state machines, I can't use it within async methods as well, because of the state machine modifications that go on there. With a ref return, modifying the reference is exactly the same as modifying the original value, because it is the original value. It's a reference to the same thing. So they are now, even though it's a value type, it's a reference to a value type. It's the same object, and you're modifying it, and you're modifying the original value. This has a lot of interesting repercussions. There's a few interesting things you can do, and things which it's perhaps a little bit hard to get your head around. So for example, you can return a reference to an array element and update it in place. So if I have an array of items here, I can return back a reference to the item in the middle of the array, and I'm seeing the original object, but I can modify it because it is the original object. I can still work with it and modify it. So how to work with this is simple. It's just adding a bit of syntax. We add the ref modifier to the method declaration return type and to the return statement itself. Okay, so that's great. We can return references to local. We can return references to value types. How do we use them? So we use a ref local, which is another feature as part of C# 7.0, and we use that to store the ref return result. We have to have a new feature here because we've got different return types. So if I've got a method which returns an int, I can assign that to an int as a local variable. If I have a method that returns a reference to an int, I need to have a reference to an int as my local variable. And before C# 7, we didn't have that. C# 7 introduces that, and that is what a ref local is. So there's implications with this as well. If I try to assign a ref return to a new variable, it will create a copy because the variable is a value type, not a reference. So remember, the signature, if we had a look at the IL, would be int ampersand, and we can't assign that to an int. So it would just get a copy of it. And so a ref local is a variable that is a reference to a value type. It's a way of writing and telling the compiler that this variable is going to be a reference. And it sort of essentially now has a reference to the original object, and they are now the same objects. They've just got different names in your code. So we can use this by using the ref modifier when we're declaring a variable there. And one thing to be careful of is that type inferencing, if you're using the var keyword, won't work as you expect. So type inference, if you just use var, you will get the value type itself. You'd get int. You need the ref modifier to also make it work as you'd expect. So you need ref var to actually then have a reference to an integer. So let's pause there, and we'll stop and have a quick look at some examples. So can I just quickly check that everything's all right and you can see the screen and everything's okay? Real happy. Yep, that's looking good.
Yes, everything is properly. No artifacts this time. Audio is good.
Magic. Right. Well, we'll carry on then. Brilliant. So, okay, I've got a simple project here which has got a number of different examples in it. It's got a few sort of tests. It's got a few classes and a few tests which we can do to assert basically our knowledge of what's going on with these reference semantics. So first of all, I have a struct here, which is a point. It's just a simple 2D point, x and y. It's a float. They're public. It's mutable, and it's just as you'd expect. I then have an enemy class, which has a constructor which takes in a point and which saves it as a field there. I then have two methods. I've got a get location, which returns me back my location of the enemy there, just as a point, and I've got a new ref return there as well. So you can see here we've got get location by ref is the name of the method. We've added the ref modifier to the signature, and when we need to actually return the value, we've got return ref there as well. So we've just added these new keywords in the right places to make this work. So let's just assert a few things about what's going on there. So here we're creating a new enemy, we're creating a new point, X and Y are both 10. I can call enemy.getLocation. This is just normal return me back a point, and we're assigning it to a point, and we can then say, okay, location.x equals 12, and we can assert here actually that this is working with a copy. So as I was saying before, if you've got a normal return of value type assigned to another value type is a copy, you're not modifying the original value anymore, you've got a copy. And we can just assert that. We can say that the local location is 12, but the one from the, if we get the value again, it's still 10 on the enemy. Now we can use the enemy get location by ref value here, but if we assign it just to a point like this, again, this is a point, a value type. It's not a reference to a value type. So this is going to get a copy. So even though the method is returning it by reference, the compiler will actually make sure that that gets assigned as a copy there. So we can have our copy, set the value to 12. We can assert that's true. But if we get the value again, the by ref value, it still hasn't been modified because we're working with a copy. And just to illustrate the point there again, we can do the same thing with var. var does not do the type inferencing about the reference modifier, the ref modifier. It will just create another copy going on there. What we have to do is use the ref keyword. So here we've got the ref var keyword to declare our type, and we're going to have it as a point, but it's a reference to a point. And when we call the method, we also need to use the ref keyword there as well. So we've got more keywords going on to do it. And now if I do location.x, set that to 12, and if we assert things, we can see my copy is still 42, my location is 12, and I can do get location, and it's actually changed the original value because I've returned it back by reference. So let's just quickly run those tests. We should be all nice and green, and that'll prove that everything's okay. So good, we're green. There's one more thing. There's one more test down here, which is a really interesting one. Because we're returning things by reference, we can do crazy things. So we can actually have a method call as the left-hand side of an expression there. So we can do get location by ref. This returns me back a reference to a point. I can then create a new point as part over that reference, and that will replace the value there like that. So basically don't do this because that kind of hurts my head. I can't read that so well. It's like you're assigning something to a method call, which is just wrong. So I'd avoid that if possible. Okay, so let's move on. So we've now been able to have a reference returned to us and kept locally as a local reference. Let me rephrase that. So we've now got the ability to return a reference from a method and store that locally as a reference, and we can modify the value that has been returned to us. This might be dangerous because we might have something which we want to return by reference because we don't want to do any copies because it's cheaper, and we want to have these reference semantics. But we also want to enforce you to stop you from changing it. So the example here is if we've got a point that represents the origin of our game, 0, 0, 0. If we return that back as a reference, then it's possible to change it, and that could introduce some really crazy bugs in our code. But what we can do instead then is a C# 7.2 feature, which is a ref read-only return. So we can actually tell the compiler that even though we're returning back a value by reference, you're not allowed to modify it. So it's going to return you back a read-only reference to this object. When you assign it, you have to use ref read-only var as keyword. So we're getting a little bit of keyword soup going on here, but at least it's clear now what's going on here. We know what's happening. And the compiler enforces read-only here with errors, compiler errors, saying you're not allowed to do this, and also defensive copies. So for example, if we try and assign origin here, which is a ref read-only, to a var, we'll end up with a copy of it. So we get a defensive copy. If we swap back to our tests, you can see this in action as well. So I have another struct here. Again, public XY value. I can set it as set up in the constructor. I have a method here which is useful. I've got a translate in place. So it's a mutable struct, and I can pass in my delta values, and I can change X and Y and have it mutate the mutate the point in place. I've got two different origin values here just to prove a point. I've got an origin for 0, 0 here and set as a reference value here as a ref return property. It's not just methods that can do ref returns, properties can do ref return as well. And then we also have a static read-only origin point here, and I'm returning this as a property of ref read-only point as well. And again, even though I've got ref read-only as my keywords and the method signature, I only need ref return as the actual return statement. So just to prove a point, we've got a non-ref variable receives a copy here. So if I'm using pointer origin, that's just nothing being passed by. It's passed by reference, but we're passing it into a local a var which doesn't include the reference there, so it's a copy. If I change that to 42, that's true, but I haven't changed the origin. But now if I have a ref var of the same property there, if I change that, I've now changed the origin for my game, and I'm going to have some crazy bugs which are going to be very hard to figure out and fix. So we can now use the ref read-only item here as well. So we've got our read-only origin point there. We're calling the property with ref, and we've now got a few extra keywords going on here, ref read-only var. If I want to change one of the public properties on this, then I can't do it. I'm not allowed. There's a compiler error to tell me that I can't modify these struct members here. You can't modify. You get a bit of a sort of a legalese version of the message there. Can't modify struct member when accessed struct is not classified as a variable, but basically is telling you you've got a ref read-only struct which you can't modify. So that's just a compiler error. I can't do much about that. And so in the end, this isn't testing much at all because I'm not even allowed to change anything. So those are obviously going to be true. What's going to be slightly more interesting is if I call this translate in place method. So this is going to modify the method in place. So this is going to, the point itself is going to modify its own data. So this should work, you'd think. However, fortunately, the compiler doesn't let that happen either. So we've got our ref read-only var. So we've got a read-only copy here. And Ryder's being very helpful here and is actually telling us that there's something going on. And it's telling us that we've got a possibly impure struct method called on a read-only variable. So the struct value is always copied before invocation. So what happens is, at this point, we've got a variable, a reference variable, but when this is called, it's actually called on a defensive copy. So a copy is made of the struct, and then the method is called. And because we're called on a copy, the values themselves don't change. So we are set to 0. So in the end, we've got a couple of tests which actually don't end up doing much because the compiler is enforcing a few things for us. But we've got that defensive copy in there as well. And we should be all green, and we are looking good. Okay, so that's nice. We can now say that when we return a value, we're no longer allowed to modify it. What about passing values into a method? So right now, we've already got the out modifier and the ref modifier on parameters. So I can do ref as a parameter argument there, and that's something that the value is passed in and passed out again, and anybody could change it. We've got out. I can't pass a value into it, but when I get a value out of it, then it has to be set. What about the missing object there? And that's in, and that's what the in parameter does. So again, a C# 7.2 feature. It's an argument modifier for methods there. And basically, it's telling you, the compiler, that the method is not allowed to modify the value that's passed in. So if I'm passing in a couple of points into my method here, then they're passed by reference. But again, the compiler is going to enforce safety. So if there are any methods called on those points, then another defensive copy is made, and we are working with a copy of the code rather than the original value. And we can quickly see that in action with another quick test. We have another version of the point object. Again, we have mutable X and Y values, and we've got our translate in place object so that the point can mutate itself. And we can, again, proving a point, we can say that the method can mutate its own state. So the translate in place object moves the X by 20, and we can assert then that actually works, and that's great. If we try and use this with an in parameter, then I get a compiler error. I can't change anything on my point object because the compiler says it's not classified as a variable. It's a reference which you're not allowed to modify. So the compiler will actually throw an error at this place. But what's interesting is that I don't get a compiler error on calling my method, which is allowed to mutate it in place. So the point can technically mutate itself. But again, we've got the warning here that we're going to be making a copy before it works. The compiler has put in a defensive copy in place so that we're going to make a copy of the object and call that on and call the method on the copy. It mutates the copy, and the original value is as it was. And again, it's compiler error, so I can't really do much to show with that one. But what we can do is we can say that we can show this in action here as well. So if I've created a mutable point, assert that it doesn't get changed, but I'm going to call a method now which has got the in parameter set there. So I've got my in parameter here. And again, we can prove this is the case. We get a warning there to say that we're being called on a copy, and we can prove that it doesn't work. We can try and be sneaky as well. And if we pass it in as a ref, that's in and out. So we can actually modify that both ways. So we can't get rid of this defensive copy issue there. If you can see although it's a short method parameter name there, we're getting another error there to say that we can't use ref on an we can't use ref on an in parameter there. So the compiler is enforcing stuff for us, and it's making sure that everything is safe. And again, we're finding it hard to write tests which actually prove stuff there, because the compiler is now starting to tell us things at compile time. But again, we've got green ticks, and we're good to go. So we have one more feature really, which is part of this set of features that we've got as part of reference semantics, and that's the read-only struct. And this one is all about fixing the defensive copies that were happening there. So if I'm using an in parameter or the ref read-only, then those can create the defensive copies. And and that's because the compiler doesn't know if the struct is going to mutate its own state or not. And so you're trying to say, I want this parameter to be an in parameter and not modified, but the compiler can't enforce that, and so it has to make this copy for you. And we want to avoid these copies. That's one of the points of doing this. If we're passing things around by reference, we want to avoid these copies that are happening. And so read-only struct fixes that. Read-only struct tells the compiler that this struct is not going to be modified and can't modify itself. And it basically enforces, tells the compiler will then enforce that all fields and properties are read-only, and the struct becomes immutable. And this is now sort of more efficient. We can pass things around. We can pass things around safely as an in parameter or as a ref read-only parameter. And we know that no copies are going to be made when we call the members there. So this is useful for performance. Again, calling out the fact this is a micro optimization. And let's just quickly see that in action. Okay, so okay, here we go. We've now got a public read-only struct, and we've now got read-only floats there. So if I get rid of these read-only keywords, the compiler is now telling us that read-only structs must be read-only. So I get a compiler error even trying to have a mutable struct here. So that's basically it. It's game over. I can't do anything else here. If I try and do my translate in place object there, I get compiler warnings because I can't modify my fields. And so I've got my ref read-only point as the origin there, and even if I try and use this and get a copy here, I can't change it because it's an immutable struct, and I get a compiler error. So that doesn't do anything. If I have my ref read-only return value here, again, I can't modify it. Even though it's a reference to the original value, I can't modify it because it's immutable. It's read-only fields. And obviously, I can't call the translate in place because the translate in place object doesn't work. So these tests don't actually do anything. They just basically make sure that everything's 0. I'm protected by the compiler, not even at runtime. I'm protected upfront with compiler errors telling me that I can't modify things accidentally, and I can't run on what am I trying to say? I don't know. I can't mutate it. I can't change it. I won't going to have defensive copies. I can pass things around by reference, and everything works as I'd hope. Okay, next bit of this as well is that all of this is just C# compiler changes. There are no changes to the actual CLR itself. So all of this has been available to use in the CLR, I think, pretty much since day one, and it's just compiler changes that have happened. So, for example, the return type is changing it from int to int ampersand. You know, it works in the IL before we even made any changes to C#. So this can work in any of the projects that you're working on there without any changes to the CLR itself. So there's one last thing which is useful and interesting, and it's a bit weird when you first look at it, but it does make sense. And this is a ref struct. This allows you to declare a value type that can only be stack allocated. So you can't create this on the heap. You can't put it as part of a reference type. So if I had a ref struct to represent my 3D point, I couldn't put it as part of an enemy. It's not allowed. Ref struct is not allowed to be embedded inside another type of reference type. And there are very specific reasons for doing this. And the implications as well are that it constrains the lifetime of the ref of the struct to the calling method. So if it can only be allocated on the struct, if it can only be allocated on the stack, I've got my stack there. When the method finishes, it's gone, it's cleaned up, and it's gone. So there's a lot of constraints there. Constraints the lifetime. There are problems so that it's not allowed to be boxed because you can't put it inside of another object. You can't use it inside a non-ref struct because a non-ref struct can be boxed and put inside an object there. You also can't use it with async methods or iterators or be used as part of a generic parameter. So there are very, very limited use case for this, but it's really, really useful. So one of them is for working with stack alloc memory. So you can sort of allocate that on the stack. That's great. But the main reason is for using span of t, which is a really useful type. And I'd just like to finish off now by sort of talking about span of t, what it is, and how it can be really useful. So span of t is a fairly new type. And it's designed to unify working with any kind of contiguous memory, a big block of memory all in one chunk there. So this is things like arrays, array segments, strings and substrings, but also things like native memory, stack allocated memory, and so on. Any block of contiguous chunk of memory can be wrapped in a span of t, and you can use the same API to work with it. And basically, it provides an array-like API. So it gives you an indexer, so you can index into your block of memory. There's also a read-only span of t type, which provides a getter index only, so you can't set it, you can't change it. And also, it's type safe. So span of t, it's a set of elements of type t. So whenever you pull out an element from the span itself, it's going to be of type t, and you know that, so that's good. The other key thing really is that it has array-like performance. So it's not quite as fast and as good as an array, but it is very, very close. And the more recent .NET runtimes have got special support baked into the JIT, into the runtime itself, to make this as fast as possible. But one of the key things that it enables really is slicing. So you can actually create a new span of t based on a subsection of an existing span without allocations. So if I have a big block of memory representing an array here, that can be one span. I can then create a second span, which is just a chunk out of that array there without any allocations there, which is going to be a great way of being able to work with data and subsets of data without allocating any memory. So how does it work? Well, it's a value type. Span of t itself is a value type, it's a struct, and for down-level platforms, it is available as a NUKE package for .NET Standard 1.1 in the system.memory package, and it's available sort of in the platform for newer frameworks. And there are also APIs and overloads in the base class library which allows you to use this. So you can create a span from a string, for example. You can use it for streams as well, and also for working with parsing strings as well. And when I was saying before about know your platform, this is kind of where it all comes in. These APIs are all about using these ref semantics as well, these reference semantics, these ref structs, the ref read only, span of T, all of this sort of comes together in this kind of section here. There are several types: the span of T, read-only span of T, and there's also a memory of T, which is a bit more complex. I'm not going to go into that today. I'm going to leave that as an exercise for the viewer, but it allows you to do a whole bunch more sort of similar stuff, but without necessarily some of the constraints, really, of span of T. There are two versions of span of T itself. There's a portable version and a fast version, and the fast version requires runtime support, whereas the portable one is for down level systems there. And it's not fair to call them fast and slow. One is definitely sort of portable, whereas one is fast. The portable implementation, as I say, works more on down level platforms as well. So .NET Standard 1.1, which is the .NET Framework 4.5, which has been out of it's been out of support for a while, I should think, but it's still available on those there. And again, it's important to point out that portable is not slow. It's even though you've got a fast implementation, the portable one is not slow. It's just not as fast as arrays. So you don't get quite up to the array-like experience, but it's still good. The way this is implemented is that a span of T has three fields. You've got a reference to the object itself. So your block of memory, you've got a reference to that, your internal offset for where it starts, and then a length for where it finishes there. So three fields, it means it's slightly larger than the fast version. Dereferencing is slightly more complex because you have to go to the start of the object, add your offset, and then add another offset again. But it's not a big difference. The fast implementation is built into the runtime. So .NET Core 2.1 and above have it built in there, and it's only got two fields. So instead of when you've got your whole object here, you actually has one pointer to the start of the block you're working on, and it's an internal pointer. So instead of having a full block of memory there and starting some point in there, it actually points inside an object, and it keeps then the length of the slice, the span that you're working with there. So this gives you slightly smaller than the portable implementation, and accessing an element is, again, a slightly simpler operation because you're just going directly to the start and adding on your offset there. But what makes it the fast implementation is that the framework knows about it, the runtime knows about it, and there are specific JIT optimizations to make it work as fast as possible and work as close to an array as possible there. So the array type itself has proper support built into the framework too, into the runtime. And the runtime recognizes the array and does specific JIT optimizations to, for example, getting rid of the bounds check once you're inside a loop there, which can really speed up a loop. And span of T has similar support in the framework as well. So all these things then basically give you very close to array performance. So it's a very good way of working with any type of memory, whether it's arrays, strings, native memory, pinned memory, stack allocated memory, and so on. So the big question is, what does this have to do with ref struct that I was just talking about there? And the big point really is that all of these fields in the span there, whether we've got two fields or three fields, they need to be updated atomically. You can't have it so that one part gets updated and then you do a thread switch there. You can't use synchronization because the whole point is performance, and so you don't want to be putting locks there, which is just going to slow things down. And so you have to update everything atomically, all at the same time. Another reason is that the internal pointers of the fast version, they require special garbage collector tracking there, and having too many of those active at any one time is kind of expensive. There's a lot of overhead, really, comparatively speaking, to tracking that there. So you want to keep the number of spans alive at any one time to a low number. So, and then also you can say, how can you have a span of T represent stack allocated memory if span of T was on the heap? If span of T lives on the heap, and has a lifetime which could potentially last as long as the lifetime of the application, how do you deal with stack allocated memory, which is going to go as soon as the method finishes? And the solution is that span of t is a ref struct, as you described a minute or two ago. This is so it can only be created on the stack. So it's got the constrained lifetime, it's got the single thread access. You can't swap to another. You can't sort of swap threads in the middle. You can't swap execution into an already active method there. You kind of they swap as a whole thing there. So you're safe within a single thread there. And so the ref struct fixes all of these kind of potential problems that you've got going on there at any one time. So let's have a quick look at that in action. I have another method, another class here with some tests. I have a couple of fields which we're going to work with. So we've got a string here, which is effectively an array of characters, but it's a string. And we've also got an array of integers going on here, 1 to 10. So we have a number of different tests here. First of all, I'm going to convert my string. I'm going to use one of those overloads in the base class library to get a string as a read-only span of characters. I'm just going to assert that I can use it in the same sort of way as I can then as a string. So I can call length on my string and compare it to the length of my span. And I can also do span.equals and compare that to a string. So if we've got some overloads on a read-only span of char, which gives me some extension methods for doing things like string comparison and starts with comparisons and so on. So not terribly exciting in that one, but things get a bit more interesting when we do something like this. We create a span out of my string, and then we slice that at the offset 6. And now I can assert that actually my slice is now just the word world from my hello world string, and I can do slice.equals on this there, and there's no allocations going on there at all. It's all fairly straightforward slicing and getting a nice read-only slice within a substring without allocating. If I wanted to do that with substrings, if I did mystring.substring6, that's an allocation. It's going to allocate a new string for me. So I can do this here much more cheaply. And then the final test is this one here. I can create a span of numbers, and I can get a slice out of that. I can start at offset 3, get the next 5 items there, and then within that slice, I can set a value of 100, and it actually updates the value in my original array there as well. So I can work with a slice in the same way as I work with a normal array, and it can affect the original value there, which is a great way of working with reference semantics. If I just run that one, now get all green ticks. So I've got another test here as well, is just a quick and dirty assert to make sure that everything is allocation free as well. I get the total memory and save it there. I tell the garbage collector, don't do any garbage collection until I say so. I call my original tests. I say, okay, you're allowed to do garbage collection now. And then I just assert that no memory has been allocated in that time there. And we've got a green tick there that is all works as expected. And we can do those things without any allocations at all. So that brings me to the end of everything there. I've got a few useful links for you here. The tests which I've just been running there, they're on GitHub under the Ref Semantics project there. And then there are a few really, really interesting posts and documentation about some of these things here. The Microsoft documentation for this is very good, explaining what the reference semantics are and what they do and how they can work with them. And similarly, a bunch of really good topics covering span of T and how you'd work with it, what it's for, and also some of the JIT optimizations for making it work fast and within the runtime itself, nearly as fast as arrays themselves. And also then there's the link to the value task blog post, which I mentioned sort of earlier on in the talk. And so that brings me to the end of it. I think I'm about done there. So I guess, does anybody have any questions? Let me just see.
So, gentlemen, any questions? Matt is not going to stay here for a long time, and that's your chance. Michael? Any question there?
So I can't see any in the chat so far.
No, there is none. I was trying to motivate the people there. Matt, I have a question for you if nobody throws it. What do you use for dynamic code profiling? What is your tool or set of tool belt of preference?
So there are a kind of different number of things we can do with that. So JetBrains obviously have a number of different tools. There's .trace and .memory. .trace for performance profiling and .memory for memory profiling. But the other thing is, Rider's got this feature called dynamic program analysis, which is pretty cool. And that's doing this lightweight analysis, and it's tracking a whole number of different a whole number of different things there, quite a lot of things on memory allocation. And so it will capture allocations that happen while your code is running. And it kind of does a bit of an analysis on those once you're done, and sort of flags some of the issues there. So if you are doing allocations over a certain threshold, for example, there it'll flag those up and say, are you sure you want to be allocating this many of those objects during this run? Or if you've got a large number of garbage collections, it'll sort of flag those kinds of things up there. And it's about trying to give you the some of the results of profiling without having to do all the hard work of actually profiling it up front. So it runs just in the background with very little overhead. You don't notice it running, and it will it'll flag up some important issues for you, which you can then investigate, look at, and see whether they are something which you should be looking at to fix.
That sounds really interesting. I should try that part. I don't know. How do you get the tooling?
I'm sorry?
How do you get this?
It's just part of Rider, so it's built into Rider itself. So jetbrains.com/Rider.
Yep, that I know. Okay.
Yeah. Unfortunately, it's Windows only. It uses a lot of ETW at the moment. I'm on Mac, so I don't get to see much of the benefits of it.
I don't have a problem with that. I'm a Windows user, so.
Also, there is benchmark.net, which is also done by employee of JetBrains, I have to say.
Right. Yeah, and
Andre performance tooling. Yeah, Andre, which is, to your point, measure first, and benchmark.net is very good to measure first.
Yes, absolutely. It's used by the by Microsoft themselves on the compiler and on the runtime, on the framework and everything. So it's a very mature, impressive framework. So yes, these kinds of things.
Matt, we have a question. So Matt, it's asking if we have something similar outside of Rider as a Visual Studio plugin.
Not that I'm aware of, actually. I think that the dynamic program analysis is. I'm not aware of anything like that for Visual Studio, to be perfectly honest.
I believe I did a blog post in last year about NDepend, which is similar to SonarQube. I really like it very much. And I think it does this kind of measurement. I haven't explored this, but I believe here I think we have some stream of performance tuning. So we maybe should invite Patrick Smachia, the author of NDepend, and get him to expose it. But I think it would be a nice follow-up.
Yeah, absolutely. I'm not overly familiar with all of those features of NDepend, so I can't comment, unfortunately.
What about ReSharper? Isn't that basically the Rider for Visual Studio?
Yes, it is. But this was a Rider feature rather than a ReSharper feature, mainly for performance reasons. Ironically enough, so Visual Studio is a 32-bit process, and having too much going on inside that 32-bit process can cause issues. It definitely causes garbage collection and throughput issues. And so Rider is a sort of 64-bit process. Well, in fact, it's multiple 64-bit processes, so it can sort of manage memory a whole lot easier. And so, DPA right now is a Rider-only feature. We'll be bringing that to ReSharper at some point, I think, but I'm not sure on the plans for that just yet.
That sounds like an excuse to jump into Rider just to try this feature. I think it's a bit of a game changer if you are into high performance.
And I have to say, if you're on the Mac, it is, and if you want to have a Visual Studio-like experience, ReSharper Rider is the only tool that you can use there.
I'm biased, but I agree.
Yeah, because benchmark.net, for using that, you need to program a test. So it does not run with Rider. What I understood from Matt's explanation is you run it and it does a dynamic code analysis, how it runs, and provides already out-of-the-box optimizations and can even implement them.
Sorry, you're talking benchmark.net or the dynamic program analysis?
I am comparing both of them. I'm saying that if you want to use benchmark.net, the library or NUKE package, you need to program a test, basically. You need It's just for assessing how much time would it take to do this loop or iteration or task 100,000 times, right? That's a question you have to make. And with Rider, you run your code and you get the output right away and optimizations.
That's it. So you don't necessarily get the optimizations, but you get information about things that have happened during that run, and you can sort of flag it up and highlight issues which you might want to investigate further and see what you want to do to repair that. So, for example, that tweet's a great example there. So, spotting that 13 gigabytes is being used on application start. That's pretty awesome.
We have one question from Pascal. Hi, Pascal.
Hi.
Does for each on an array introduce more costs?
Very good question, and I'm not entirely sure of the answer because there are different implementations of how these things work in the runtime. So, for example, if we were looking at for each on a list, if you're using list directly, list of t, then there isn't an allocation because the enumerator itself has got a full implementation of enumerators as structs, and so those get used directly. If you use for each on an interface of I list of t, then it will try and use I enumerator, which boxes, and so you're going to have an allocation going on there. As for arrays are handled specially in the runtime. So if you had a for loop, a simple for loop, I know that the JIT does optimizations to sort of avoid bounds checking and everything. I don't know for sure what it does with a for each loop. I would suspect that a for each loop with an array has those optimizations as well, but I wouldn't know for sure. Again, the best thing to do is profile benchmark. That's a great example for benchmark.net, where you can have 3 or 4 different scenarios, for each of an array, for of an array, over a list, and so on, and see the differences between the different benchmarks.
Cool. We have a continuation question. It's an enumerator. Is an enumerator generated for an array inside a for each loop?
Again, I don't know the answer to that. I'd have to look into it. I don't know.
Me too.
Yeah.
So thanks, Pascal. Any more questions? I mean, for me, it was a great talk. I learned a bit about missing topics like local functions and value tasks, which I definitely have to dig into them. I was not really fully aware of them. And span of t, I read a bit about it, and I was playing a lot with gRPC and with byte arrays, and that seems like the right thing to use for these kind of situations, for parsing a very big byte array.
Yeah, absolutely. Span of t is going to be brilliant for parsing. So, I mean, if you think of JSON, for example, you're going to basically be making a whole load of different substrings for all the values that are in there, and even for the keys. If you've got like a key value map inside a JSON file or a YAML file, for example, you're going to have allocations for every single one of those keys. And there are ways of, if you could write something which is entirely using span of t to do all that. In fact, I think Microsoft did with system text JSON. I've got a feeling that's using span to do parsing of JSON.
Yeah, it's kind of like a window into the data. Like you can open up a new window without the cost of copying.
Yes, absolutely. And with the right overloads, like with the string overloads, you can then see that you can still do the you can still have string comparison methods, and starts with, ends with, equality, even with like ordinal ignore case. on these slices of a string. So you can do equality based on a substring without allocating the substring, and that's very cool.
Nice.
Yeah.
So I guess we are done with your talk, and thank you very much. I mean, it was great. So
Yeah.
Thank you.
Really, thank you. Thank you both. These
Yes.
topics were both great, and I think
Yes.
people enjoyed it.
and,
Well,
and
thank you very much for having us.
And again, I want to congratulate again Matthias for his resilience. That was amazing.
Total pro.
Yeah, I wish I was more pro like Matt, where nothing happened. Which you said,
Yeah, that's how you measure a pro. Is that the things didn't fail on you.
Yeah, that's what I was chatting to Jose while Matthias was talking, and that's exactly what I said. When a speaker is more seasoned, has more experience, you can see that when things go wrong, you don't panic. You just keep on doing your stuff.
Yep.
Yep.
Also, you
I
can
can't
always
say I knew what to do.
nobody knows. That's a secret. Also, you can tell Matthias use a Mac. Right?
He is using a Mac. He is.
I actually have a Mac, yeah.
Oops.
Yeah.
All right. So from both of us, Matt and me, also thanks for the invitation. It was really nice speaking to you, and I guess it's really interesting how much audience you had as well. I mean, from different parts of the world. I guess that doesn't happen so often. Yeah, and I just want to add, if anyone has any further questions, Matt and me, we are both on Twitter, so you can reach out. And yeah, thanks from us as well.
Yeah.
Thank you very much.
Thank
Goodbye,
you.
guys.
Okay.
Have a nice evening.
Bye. See
Bye,
everyone.
everyone.